This is problem number 30 from chapter 10. A group of transfer-bound students wondered if they would spend the same mean amount of on text and supplies for each year of their four-year universities as they did at their community college. They conducted a random survey of 54 students at their community college, 66 at their local four-year university. And they got the sample means for each. And they have a population standard deviation. Okay, so let's do this. I guess it's good to identify the two different populations or samples that you're going to be dealing with. We have a four-year university and a community college. So let's look at the first set of data comes from community college. So let's mark that as a CC for community college and four-year universities. And we can start off with an N of 54 students at their community college. So let's call this sample 1 and sample 2. For sample 1, the community college, there's 54. So we'll label that as N1. And for the four-year university, there's 66 students. The sample means were 947 and 1011 respectively. Now it's important now that we've set this community college first and four-year second, as they've presented it that way. And so anything that comes after that, when they say respectively, it's going to go in the order that it was presented. So community college was first. So when they say the means were 947, that's X1 bar, the mean for community college, $947. The mean for the four-year universities is 10. That's 1011. Now the standard deviations here, notice a keyword, the population standard deviation. So we're looking at sigma. It's important to get our notation correct here for standard deviations. Our sigma is known to be 254 for the community college. That's a large variation compared to 84 or 87 for our four-year counterparts. It says conduct a hypothesis test to determine if the means are statistically the same. So in this case, if the order is really not going to matter, we'll do this for community colleges, and mu2 is going to be for four-year universities, and statistically the same is basically an equal sign. Now this equal sign will have to go to your null hypothesis, and so your alternative would be the opposite of that, not equal to. So let's set up our H0. Our null hypothesis is exactly what the claim is saying. And remember, this hypothesis test is a test on the claim, or on the null hypothesis, which in this case is the claim. Our alternative hypothesis would be the logical opposite of that. So that would be a not equal to symbol. And we are all set to get the results. So in our calculators, oh, by the way, this is going to be a test for two samples and for the mean. And our choice again is either a z-test or a t-test. And in this case, our sigmas are known. That's the population standard deviation is known. So we're going to use a z-test. And our calculators, let's go to stat, test, and 2SAMP z-test is the third option. We have statistics that's summarized for us already, so we'll go ahead and hit down. Our sigma 1 is known to be 254. Our sigma 2 is 87. Our x1 bar, 947. Our n1 is 54. x2 bar is 1011. And our n2 is 66. Alright, so that takes care of all the statistics here. Scroll down one. Our mu1 is alternative hypothesis statement. Our mu1 is not equal to mu2, so we need to select this not equal to symbol and calculate. So let's have it calculate. Okay, your test statistic is, since you're using the z-test, 2SEM z-test, you're using the standard normal distribution or normal distribution. So your test statistic is going to give you a z value. Z is equal to negative 1.768, and that is fairly close to 0, almost to the edge of our 2 standard deviations away. Our p-value is 0.0769. That's almost, let's go with 0.0770. So that's our p-value. Now, they didn't give us an alpha to compare this to. Our alpha is usually 0.05, or sometimes it's 0.10, 0.10. But if we compare it to 0.05, it looks like the p-value is still a little bit bigger than that. So our p-value is bigger than alpha, so it was close, but we still have to fail to reject the null hypothesis. And that is the claim, so we were not able to reject the null hypothesis. So, sample data. Given the sample data, we were not able to reject the claim that and the claim, remember, was they will spend the same mean amount on tech supplies, so that community college students and 4-year university students spend the same mean amount on texts and supplies. We want to be careful here that just because we did not reject the claim that we would actually accept it. Some people like to say that, but remember that this test is actually a test to reject the null hypothesis. And if we didn't reject it, it does not necessarily mean we accept the claim. We can probably go into further statistical testing to actually prove that they're significantly the same. But in terms of this particular hypothesis test, all we were able to say is that we were not able to reject it. So I guess if you want to come to that conclusion, I would be okay with that in a test situation. But in general, we don't want to say we accept the claim if it was not rejected. I think there's a deeper level of understanding that we have to go through to be able to discuss the supporting or failing to support our alternative hypothesis if that happened to be our claim. So just a little side note, and keep that in mind when you're doing the test. What I can do is I can provide a flow chart that might help us find a good wording for the final wording in non-technical terms to complete your hypothesis test. Alright, well, I hope this helps with your homework.